Suppose f prime of 7 exists. What can be said about this limit? Oof. This is our little warm-up exercise. So, no chatting. Nothing in the chat. No chat. We use microphones here. Talk. We use our big boy voices. What are we thinking? So I'm not going to give you any time to think. I'm not going to give you a timer. So start thinking about this, and whoever thinks of something, it might not be correct. It might be correct. There's a lot of things you can say about this limit. Or maybe there isn't. Maybe actually this whole thing is a trick. Maybe the trick is actually you can say nothing about this limit. It can be anything you want. Now, who started talking? I interrupted them. Bryn.
I was just gonna say, if f prime of 7 exists, then it means that the limit as x approaches 7.
Oh, you cut out. You said the limit as x approaches 7. Oh, she cut out. Do you want to type what you actually said at the very end, or say it again?
I'll just try and say it again.
Okay.
If f prime of 7 exists, then it means that the limit as x approaches 7 of f of x exists.
Okay, so that's correct. Now now there is more you can say, but what Bryn said is correct. If f prime of 7 exists, then this limit also exists. The limit as x approaches 7. Now, who wants to continue with what Bryn said? Can someone explain why does that limit exist? So Bryn is correct. This limit definitely exists. I can say that for sure. Why?
Is it because it's differentiable?
Okay, so the function is differentiable. What does that tell you? What else does differentiability tell you, CJ?
It's also continuous?
Okay, good. So that's the main thing the main leap to remember here. Okay. Since f is differentiable at 7, that means f is also continuous at 7. Remember we talked about this in a couple lectures, like 2 lectures ago, maybe? Differentiability implies continuity at that point, right? Okay. So now let's put this together. So CJ has noted that f prime of 7 exists, therefore f must also be continuous at 7. And then Bryn said that this limit exists. So what is the connection between continuity and this limit? What is the connection there?
The limit is equal to f of 7.
Okay, good. Very good. So what Dina said was that is essentially the definition of continuity. So that's about all you can say about this limit. But I mean, that is quite a lot, right? You can say that the limit exists and it is equal to f of 7. So not only, that's what I meant when I said to Bryn, you can actually say more. So not only does the limit exist, I also know it's equal to f of 7. I'll say it.
Yeah.
What's up? You want to volunteer something?
Oh, I didn't know I was unmuted.
Oh, no.
I don't know how to have.
Okay. So that's pretty much all we can say. I'm even going to write it down because that's whatever. I mean, then obviously we also know anything else that this implies. For instance, if I asked you, Alex, what is the value of x approaches 7 from the left? Can you say something about that, Alex?
It exists. It equals the limit of f of x as x approaches 7 from the right.
Good. So it also exists, and it must equal the right limit. And can we say even more than that, Alex? Can we actually give maybe some sort of value to this?
Whatever f of 7 is.
Whatever f of 7 is, right? So we can conclude that the left limit and the right limit both exist. They're both equal to each other. They're both equal to f of 7, right? Everything that goes along with this statement. But the big leap here is noting that this limit exists and is equal to 7, f of 7 rather, because of that continuity relationship.
Wait, but didn't you say it was f prime of 7?
That's right. Exactly. I said f prime of 7 exists. Therefore, if the derivative exists, the function's also continuous. We talked about that 2 lectures ago. Differentiability implies continuity.
Got it. Thank you.
Okay. You're welcome. All right, next. That was just a warm-up. So now let's do another warm-up.